Welcome. In this proof of concept, we have a control algorithm running on the Flow blockchain. This on-chain algorithm, essentially a smart contract, will orchestrate a swarm of machines and IoT devices. This blue board represents one of those machines. My machine connects via Wi-Fi and listens to directions from the on-chain algorithm. At the moment, it's also connected to my laptop via a serial bus so that we can see logging messages that the machine produces. So the machine is connected to Flow and subscribed to instructions from the controller, but the controller isn't publishing any instructions. So that's what you see here at the left part of the screen. We're just seeing heartbeat messages every few seconds being added at the bottom. Also, the machine indicates by green blinks that it's receiving those heartbeat messages. So now let's imagine the machine is supposed to execute some task when outside temperatures drop below zero, below freezing. For instance, activate a heating to prevent some liquid from freezing or to drive out and distribute ice melt. At the moment, my temperature is set to a comfortable 8 degrees Celsius. The machine is idle and we're reading 0 volts here. So let's make something happen by providing new information to the on-chain control algorithm. Such information would be coming typically via transactions from external sensors or maybe a weather service. In the right window, I will be preparing that transaction. For example, let's say our temperature is predicted to drop to minus 17 degrees. So that's the last parameter here, the minus 17. We'll submit that. And so the on-chain control algorithm processes this input and then decides whether it needs to send instructions to the machine. In our case, it notified the machine that it should start its work because the outside temperatures are predicted to drop to minus 17. The machine has already received that instructions and activated. The voltage is now 3.3 volts. You might have noticed the blue LED on top of the machine. With bursts of blue flashes, the machine indicates that it has received instructions from on-chain. So at the moment, my machine is connected to the computer so that we can monitor what it's doing. But in fact, it can operate entirely independently. To demonstrate that, let's connect the machine to this power supply. It will now reboot, reconnect to the Wi-Fi, and restore its state from the chain. You can see the voltage is back to 3.3 volts. So let's now update our weather prediction to plus 3 degrees Celsius. So below freezing turns into above freezing. I'll submit that transaction. Watch out for the blue LEDs. There we go. Instruction received, and the machine goes off because now our prediction is above freezing. So with this experiment, we have shown that blockchains can be used to orchestrate a swarm of real-world machines and IoT devices. I'm using the word orchestrate because I think it describes the application very well. For example, we would not be wanting to stream camera data from the devices and then running image recognition and pathfinding algorithms on-chain. The latency is just too high for that. I think a much better mental model is a conductor of an orchestra. So individual musicians can autonomously operate their instruments and play their tune. But the macroscopic coordination of the entire orchestra is done by the conductor. In our case, the individual machines correspond to the musicians. They're good at autonomously executing tasks they're specialized on. But it's relatively hard for the individual machines to obtain a macroscopic picture of the world state. Like like it is difficult for an individual musician to hear another instrument at the other end of the orchestra. And that's where the conductor comes in. The conductors, in our case, the on-chain control algorithms, they maintain that bigger picture. So they turn an unorganized group of individual specialists into a collaboratively working swarm. So our experiment here is a prototype. We're not quite there, but I'm confident that this process can be entirely end-to-end encrypted so that no data is leaked. An external observer will be able to see that an event has been emitted, but not what's in it. Previously, you could run those orchestrator algorithms on a centralized cloud, AWS, Google, Microsoft, to just name a few. Though that would necessitate that you relinquish all relevant data to the cloud provider, which could be a data privacy problem. And if that cloud provider decides that they don't want to do business with you anymore, your conductor algorithm just goes offline and you need to migrate to a different cloud. Alternatively, you could run your own server, but that has its own money and time cost. So with this experiment, we've shown that there now exists a third option. You can run your orchestrator algorithm in a privacy-preserving fashion on Flow, which is an open, decentralized compute infrastructure. So for me, that moment is is where blockchains have become real. So far, blockchains were predominantly used for value management, keeping account balances, tracking ownership of company shares. Of course, correctly tracking and reliably updating ownership is important, but the computational resources required are minimal. That's why value management can be done on most modern blockchains because it hardly requires any compute power. However, running those on-chain orchestrator algorithm is probably much more demanding. So why would we do that? In a nutshell, blockchains have two major benefits. First, they're open compute infrastructure where no company can decide that they don't want to provide service to you anymore. The second advantage is their decentralized and distributed nature. This makes blockchains highly resilient against natural disasters, cyber warfare, outages, etc. So if implemented accordingly, they're suitable for critical infrastructure applications. Though critical infrastructure and also home automation, by the way, frequently need data privacy. Moreover, you probably want the on-chain orchestrator algorithms to also interact for an even better coordination. So we need to add data privacy layer and then have the encrypted orchestrator algorithms interact, which would require probably a lot more computing power compared to the value management use case that most blockchains are designed for. But Flow is different. The Flow blockchain is architected to scale well beyond any other blockchain system that I'm aware of. In addition, it's about 10 times more energy efficient regarding, um, yeah, and also hardware efficient. That's why I believe Flow is uniquely suited for orchestrating a swarm of machines and devices. I'm thinking about applications such as controlling the charging of electric cars, operating smart homes, or balancing decentralized renewable energy production from solar, wind, biogas, etc. In broader strokes, optimizing energy usage, saving cost, and empowering users to control their own data. I hope you found this as exciting as I did. Thanks for watching.